Stanford University.
Most of us are walking around campus not paying attention to what's below our feet. But actually, there's a vital aspect to life underneath all of us. I'm Scott Fendorf, and I'm here to tell you about the dirt on Stanford. I teach a class that unravels the aspect of soils, how they're critical for life through nutrient cycling, through the control of contaminants, how they control climate, and this is a really vital aspect of life on Earth. We're really lucky here on campus to have lots of different aspects of soils. We can be on campus proper here. We can move up to the dish area. We have another layer of soils, and we're really fortunate to go up to Jasper Ridge Biological Reserve, where we have many different soil types and lots of different ecosystems.
We have lecture every week and you learn everything about soils, but then every Wednesday we come out to the field and we get to apply everything we learn.
I spent a lot of time in a lab, in a basement, running PCR gels and the like. So it really is a bit novel for me to get outside like this.
Up here at Jasper Ridge, what we're doing is giving the students an ecological construct where they can examine the soils and see how the soils develop, and from those understand the basic properties, both that the soils are providing for the ecosystem, but also in terms of the development, what the physics and chemistry and biology were that drove the soils that they're actually observing here. What the students are doing right now is they're rolling out a wire, and it turns out that the plasticity or the flexibility of soil relates to the clay content. They're getting calibrated right now, and within a short time they're going to be able to determine the clay content within about 5% just simply by feeling this wire and looking at how much it bends.
Oh, really? Okay. Yeah.
We also blend the field observation with moving back to the laboratory, where they learn analytical techniques and learn how measurements are made and bring that chemistry back to then soil processes. We really get a massive breadth of students that move anywhere in kind of the age distribution from freshmen all the way up to graduate students, and from engineering, mostly civil and environmental engineering, off to international relations.
None of my other civil and environmental engineering classes have gone out into the field, so seeing as that is going to be a big part of my job is field work, it's nice to have this opportunity.
The environmental engineering program doesn't really teach us a lot about soils and the subsurface, so I definitely like being here at Stanford because they allow you to branch out.
Soil seems like it would be a really confusing chemical composition, and it is, but it's easy to pick up, which I thought was really surprising and awesome.
What's the difference between a mollisol and an alkali? I want to make it the most fun class that the students have had here at Stanford, but at the same time making it a really hardcore science class. One of the main things I want them to learn is the difference between soil and dirt, and that sounds funny, but the difference really tells you about the properties of soils. Dirt is just a stagnant entity of organic matter and mineral matter. Soils are in place, really developing through a whole host of different processes. They're a non-renewable resource that's critical for life as we know it, particularly in terms of humans for food production, but also for water storage, for maintaining clean water, and that really without soils we're not going to have life as we know it.
For more, please visit us at stanford.edu.